So new chapter, we're starting chapter 11. We're going into our last unit, all about physical science. Remember, physical science is physics and chemistry. That's science that also includes math. We are going to be doing chemistry specifically, and throughout this chapter, we are going to be talking about types of matter, states of matter, properties of matter, mixtures, and solutions. So for this lesson, we're going to start by talking about what are properties of matter. And you may remember that before there have been a couple of assignments where I've asked you to list some physical properties. So today we're going to be talking more specifically about what are physical properties and how do they differ from chemical properties. So first thing is to define a substance. And I know that kind of sounds like it would be common sense, right? Like I know what a substance is, it's a thing. Um, so matter is anything that actually has mass and takes up space. Um, so if you have matter with a uniform and unchanging composition, we call it a substance. And what all those words mean is if you have a type of matter that always is made out of the same thing, then we call it a substance. For example, water. Water will always be, if it's pure water, H2O. That is a pure substance. Where something like air is matter, we wouldn't call that a pure substance because even though we have a general idea of what makes up air, it can vary depending on where you are. So matter is everything around us with mass and space, but don't confuse that with what a substance is, because a substance has to be made of something that it's always made of. The composition cannot change. Okay, so I apologize, the slide kind of got distorted here, but I can read to you what it says. So first is physical properties of matter. A physical property is a characteristic that can be observed or measured without changing the sample's composition. What that means is a physical property is anything, any characteristic that describes something without changing what it is or what it's made of. So things like color, things like shape, things like boiling point, because even if I were to boil it, that's not changing what it is. If I boil an ice cube and turn it into water, it's still H2O. So I didn't do any chemical reactions. I didn't create anything new. So anything that describes something without changing the composition is a physical property. So here are some examples of physical properties. You don't need to write down this table, but this is just an example table. So things like color. What is its state of matter? Is it solid, liquid, or gas? At what point does it boil? At what point does it melt? What is its density? All those are physical properties. So within physical properties, we have two main categories, extensive and intensive. So extensive basically has to do with how much you have. So it's dependent on the amount of the substance you have. So things like mass, how much of it do you have is going to affect what's its weight. The length, how much of it you have is going to affect the length. Volume is the amount of space something takes up. In case you don't know, that's important as we go through the rest of this lesson. Intensive has nothing to do with how much there is, the color. If you have more or less of it, that doesn't change what the color is. That also doesn't change the density, because the density is just how closely compact particles are. So those are things that do not depend on how much of the substance that you have. So now I'm getting into chemical properties. So chemical properties are a little different than physical because they actually do create a new substance. So when you combine something or change it into another substance, the properties or the characteristics that describe how it combines are called your chemical properties. So if something turns green in the air, that is a chemical property. That's a characteristic that has to do with it changing into something else. If something is toxic, that forms a chemical reaction. If something is highly flammable, because that would create a new substance. Those are all chemical properties. Okay. So this is not necessarily something that you need to write down, and this slide got a little distorted as well, but this is something that I thought would be good for you to look at. So number one is that a substance can change form. So it can change from a solid to a liquid to a gas. and we're going to be talking about that here in a second. That is a physical change. But this is just a table that's comparing some physical and chemical properties so you can kind of see what that looks like. So if we're talking about copper, one of our elements, it is reddish brown. It has a density of 8.96 grams per centimeter cubed. It has a melting point of 1,085 degrees Celsius. Those are all characteristics that describe it without changing its composition. There is no new substance that would be formed. Chemical properties of it would be that it forms green copper carbonate because look, it formed a new substance. It reacts with nitric acid, forming a new substance. So all the chemical properties have to do with how it reacts with something. So here's just a table that you have in your book that I thought was helpful for us to look at together. Basically, when you're looking at a property and you're trying to determine if it's a chemical or physical property, this is a flow chart to kind of help you out when you get started. So first thing, can you observe this property without changing the composition, without forming any new substance? If the answer is no, and you have to form something else, you're just going to go down to chemical properties. And here's an example of that. If it can be observed without changing the composition, then it's a physical property. Then you just have to look at, okay, well, does it depend on how much that I have? If it doesn't depend on the amount, then you can tell the difference between whether it's extensive or intensive, depending on whether it does or does not depend on the amount that you have. So now we're going to talk about physical and chemical changes. And if you have an understanding of what physical and chemical properties are, it's easier to understand the changes. So physical properties, remember, don't change the composition. They don't change what the substance actually is. So if you have a physical change, that's the same thing. That's the transition without changing what the substance is made out of. So think phase changes, changing from a gas to a solid to a liquid. All those are changing it from one state to another, but it's all the same thing. If you took an ice cube and turned it into water and then turned it into water vapor, it's still the same composition. It's still H2O. So those are examples of physical changes. Okay, so now chemical changes. So chemical changes are a little different than physical because they do create a new substance, one or more. So things like rusting, things like burning, things like oxidizing, that all form some new substance by reacting with the original substance are examples of chemical changes. So now our states of matter, we're going to do a quick overview of these and then we're going to come back and get into them each a little bit more with detail. So physical form of a matter, we have solids, liquids, or gases. In your books, also talk about plasmas and we'll talk about colloids a little later in this chapter as well. But we're going to start with solids. So solids have a definite shape and volume. What that means is that the structure of the bonds are a specific shape and they take up a specific amount of space. That's the volume. So think of a cube like here in our picture. If it's a solid, it's going to have a solid shape and it's going to have a specific volume. It's going to take up that same amount of space. Liquids have a specific volume. It's going to take up the same amount of space, but they don't have a specific shape. They are more fluid, and so the particles can move past each other, and liquids can take the shape of whatever container that you put them in. So then we have gases and vapors. They do not have a definite shape or volume. They take the shape and the volume of their container. So if you put it in a 100 milliliter flask versus a 3-liter flask, it's going to take up the volume of whatever container that you put it in. Now, the difference between a gas and a vapor, because I know in everyday language we tend to use them interchangeably, but a vapor is a substance that was a solid or liquid at room temperature and you turned it into a gaseous form. But if you were to go back to room temperature, it would be a solid or liquid. So That's why we say water vapor, because at room temperature, water is a liquid. You can add heat to it, but once you start moving closer to room temperature, it's going to start condensing back down to a liquid. So now getting a little more specific about each of these. First one, liquids. So I mentioned liquids were fluid. Fluidity is just the ability to flow or diffuse. So liquids and gases are both fluids. They both have the ability to flow and to diffuse. Remember, diffusion is just moving from high to low concentration. Viscosity is basically the measurement of how much that fluid resists flowing. So a very viscous fluid would be something like maple syrup because it doesn't want to flow very readily. Surface tension, this is something we saw. Remember when we did that lab where we were using the dropper with the water on the pennies? Surface tension is basically the force on the surface of a liquid. It's an attraction force that basically keeps the molecules combining together. Now, surfactants are compounds that will lower that surface tension. So if we were to just add that water and you start to see that bubble forming, if you were to add something like soap, which is a surfactant, it would actually lower that tension and make it harder for those water bonds to hold together. And then two more terms, we have cohesion, which is a force between identical molecules. So when you have water molecules combining together with each other, and adhesion is when you have a force of attraction between two different types of molecules. So that's why we call things like tape and adhesive, because it actually attracts two different types of materials. So next we have solids. So they have really strong forces holding them together. That's how they're able to hold that definite shape. Now, particles are always moving, even in a solid, liquid, or gas. But in solids, because of the strong bonds, they're not able to move past each other and flow. They kind of just vibrate in fixed positions. Most solids are more dense than liquids. And remember, density is basically how closely compact molecules are in a specific volume. There's a couple exceptions. So one that you're probably most common with is water. That's why ice floats, because it's less dense. That has to do with the actual shape and structure of a water molecule and basically the gaps between the connected molecules. And we have two categories of solids. We have crystalline solids, which have a specific shape and structure. And then we have amorphous solids, which their particles are arranged in irregular repeating patterns. Those are usually molten solids. Sometimes things like rubbers and plastic could be amorphous solids. And now gases. So gases, again, no specific shape or volume, because there are no significant forces of attraction. There are forces in play, and when you get to chemistry, you'll learn more about those, but none that really hold them in fixed positions or closely to each other. And because of that, gases are compressible, meaning I could take a large volume of gas and compress it into a smaller volume. You can't really do that with a solid or a liquid because they have a specific volume. There's a specific amount of space they have. Gases also have the ability to diffuse. So they move from areas of high concentration to areas of low. So if you have a gas in a vessel and you open that vessel, that gas is going to try to move out into the air because the concentration inside the vessel is very high compared to outside. So effusion is a specific type of diffusion where the gas is escaping through a tiny opening. So like the whole of that flask. So then we have plasma. So this is a charged state of matter, basically by losing electrons. And you can have charged matter in other ways as well, but plasma specifically is from the loss of electrons. And it has no definite shape or volume because it's kind of a gaseous form as well. And then we're going to finish up today by talking about phase changes. So chemical reactions tend to either fall into one or two categories, endergonic or exergonic. when we're talking specifically about heat energy, we call them endothermic and exothermic. So endothermic reactions are reactions that absorb energy, thermal energy, while changing states. Exothermic reactions release energy. So example of endo would be melting, example of exo would be freezing. I apologize for that typo there. It's just because the picture is kind of overlaying it again, like it was on the other slide. So here is a nice diagram that I always go back to when I teach chemistry classes, and I would draw this and become familiar with it because it gives you an illustration of what do those particles look like and how to know if they're either gaining or losing energy. So starting from the top, I'm going to go from the right. So we have gas at the top. And if we want to go from a gas to a liquid, that process is called condensation. And that would actually be a loss of energy. And you can kind of tell, look at all the energy the gas particles have versus the energy that the liquid particles have. If I wanted to go the other way, from a liquid to a gas, we would call that vaporization. And that would require you to take in energy. That's why we heat up water when we want to turn it into a steam. So then going from a liquid to a solid, that again is losing energy. And you can see those solid particles have a lot less energy than that liquid. That would be freezing. Going from a solid to a liquid, that's melting. We're familiar with those ones. And then going from a solid to a gas, that is going to be endothermic. You need a lot of energy to go from a solid straight to a gas. That process is called sublimation. And then going from a gas to a solid is deposition. So this is an example of where we have similar terms in science, but they have different meanings because you've seen that word before. But in this case, it's an actual phase change from a gas to a solid. So yeah, definitely put that in your notes. And you're done with lesson 11.1.